This video will go into some of the details of using ODE45 in MATLAB to solve systems, because it's also useful for that as well, and is one of the more common ways it is used beyond introduction class and differential equations. So ODE45, MATLAB's built-in solver, is useful for both first-order equations and first-order systems, provided we know how to state the system properly to get it into MATLAB. So our generic first-order system looks something like this. We have dy1 dt is some f1 of, say, t, y1, y2, and y3. Let's say we have 3 components here. You could do as many as you want, but let's start with 3. Then we have the other 2 equations as well. Now we want to represent this here as a single object, which we can do think of everything as vectors. So this I can rewrite in the form dy vector dt is some function f vector of t and y vector, where we have this y vector is y1, y2, y3, and this f vector of t and y vector should give me these 3 functions stacked on top of each other. And if we do that, this now looks identical to a first order equation up to everything having vectors on it. It's the derivative of some unknown thing equals some function of t and that unknown thing. So that can be solved in ODE45 whether that is an equation or a system. We should have to figure out how to do these 2 parts in MATLAB to get this system in the way we need it to be. Let's give this a shot in MATLAB. Let's start by writing out our 3 functions that are the right hand side. I'll just make up some functions here, and then we'll see how to get that appropriately into a structure that ODE45 can use. So now, to use ODE45, all we really need is the function f of t and y that defines the right hand side of the equation, because ODE45 just says give me that function. I will assume it is the right hand side differential equation and then solve it from there. So I need to build this function f vector that takes care of everything. So what do I need? Well, I need this f function to be a function of just t and y. Now, y here is going to be y vector. It's going to be a vector valued function with 3 components, but we'll work with that as we go forward. So what does that mean then for this function? Well, we're going to put it in a bracket because we're going to stack this function up on top of each other. And I need f1 in the first slot. It should be f1 of t and y vector. So what I want here is f1 of t, the first component of y, the second component of y, and the third component of y. Because that now says y has 3 components, and y1 is the first component, y2 is the second, and y3 is the third component. So that gets me that, and I can do the same for the other 2 functions. And I'm using semicolons here because I want these to be a vertical stack of functions, not a horizontal row of functions. Now, to see if this works, I can plug a value into f and see what I get. If I plug in f at a time of 1 and a y value that is the vector 1, minus 1, 2, I get a number. And that's a really good sign. Getting a number there is great because it means that the function is evaluating properly. If I plug in numbers to this, I get a number out, which is what it's supposed to be. Now, let's look at ODE45. Function tspan y0 for t out, y out. So let's run this from the range of 0 to 3, say, with an initial condition that we'll set in a second. So let's run this. Let's set the outputs first. I want my function f, which is the function that I want. It's set up appropriately. Tspan of 0 to 3. Initial condition. The initial condition must now be a column of 3 numbers because we have a 3-component system here. So we'll start at that same point before, 1, minus 1, 2, and then we'll suppress this for now and run it. And if you look over here, we can see what happened. T out is a 77 by 1 double. So T is a 1-column vector with 77 elements. Those are our times that it plotted. And Y out is 77 by 3, meaning I have 3 columns in Y corresponding to Y1, Y2, and Y3 respectively. So if I wanted to plot these, I can extract those out. So I can say that my Y1 values are going to be this Y out, take all of the rows, but the first column. And the same for the other two. And then with these, I can do things like plot, analyze, anything that I want. Now that I have the three functions separately, I can draw a plot of all three on the same axis, say, as a function of time. And yeah, this plot is not very interesting because that exponential function in there kind of messes things up. But we get the idea here. We get to see what's happening to all of these functions over time from this solution method. As long as we are careful in how we set up our system of equations to use in ODE45, we can use this method to solve not only first order equations, but first order systems as well. And that is built into how supplemental code for this lab is set up. It uses this method to solve these systems to sketch out phase portraits for the systems differential equations.